We're going to begin to explore this idea about the greatest common factor, factoring polynomials so that we can go ahead and discover some information. Now, what is factoring? Well, factoring is kind of the opposite of multiplication. So imagine I have some multiplication where I'm doing some a times a b plus a c. Do you remember how to distribute that? Well, that became ab plus ac. Now, factoring just reverses that idea. So let's begin with AB plus AC. We look for the term that's common to both of the variable or whatever it is, it's common to both of these two terms. We notice the A is common. So what we're going to do is we're going to factor that A out. And what's left? B plus a C. So do you see how multiplication and factoring are just the same thing but going in opposite directions? So if we can keep that in mind, we can go ahead and start to understand and get quite good at factoring. So let's look at a couple examples here to kind of get a sense of what does this factoring look like. I have two terms, 6x cubed plus 10x squared. And I want to factor out or find out what is the greatest common factor between both of those terms. Well, first of all, we start with the coefficients. Coefficients are the numbers prior to the variables. So the 6 and the 10. So what's the greatest common number that goes into both 6 and 10? 2. You're right. 2 evenly goes into 6. 2 evenly goes into the 10. So my greatest common factor has a 2 in it. Now I look at the variables. I have an x cubed and an x squared. What's the greatest common factor of x's? And what was x cubed? Let me rewrite this again to help you remember. That's 6 times x times x times x. And over here, I have a 10 times x times an x. Both of these have an x squared in them. Both of them do not have an x cubed in them. So x squared would be part of my greatest common factor. 2x squared is the greatest common factor for both of those two terms. Greatest common factor between these three terms, and we can do it between 3 terms, 4 terms, or whatever we need to do. So let's begin with the coefficients. Looks like all the coefficients are divisible evenly by 3, and 3 appears to be the highest number that I can think of. 4, 5, 6, 7, 8, 9. Nope, 3 is the only number, so 3 is part of my greatest common factor. Now we look at the variables. I have 5 y's here, or y to the 5th, 4 of them here, and 3 of them there. Well, I know there's at least one y that's common to all of those. I know there's a y squared common to all of those. I know there's a y cubed common to all of those. But there's not a y fourth or a y fifth that's common. So it stops at y cubed. So my greatest common factor is 3y cubed. And this last example, to kind of get a feel of things, the coefficients is what we look for first. The coefficients of each of these terms are 1. So 1 is part of our greatest common factor. And now we go with the variable terms. X to the 5th, x to the 4th, x cubed. X cubed is the greatest combination of x's in each of those. And then y's, looks like they all would contain at least a y squared, but do not contain anything higher than that. So my greatest common factor is just simply x cubed, y squared.